Look around you, what do you see? A world of solid objects, distinct and separate. A universe governed by predictable laws. This is the reality we perceive. But what if everything we think we know is an illusion? What if, beneath the surface of our everyday experiences, lies a hidden order? A code that dictates the dance of existence. Since the dawn of humanity, we have searched for answers. We have sought to understand the fundamental nature of the universe and our place within it. From ancient philosophers to modern-day physicists, the pursuit of knowledge has been a relentless journey, a journey that has led us to the precipice of a profound revelation. We are on the verge of unlocking the secrets of the universe's hidden patterns, the intricate tapestry of laws and principles that govern everything from the smallest subatomic particle to the largest cosmic structure. This is the code of existence. For centuries, science has peeled back the layers of reality, revealing a universe far stranger and more wondrous than we could have imagined. We have journeyed into the heart of atoms, witnessing the bizarre world of quantum mechanics. We have gazed into the vast expanse of space, observing the elegant dance of galaxies held together by unseen forces. With each new discovery, our understanding of the universe has expanded, and yet the more we learn, the more we realize how much we don't know. The universe is full of mysteries, enigmas that challenge our current understanding of physics and reality itself. The very fabric of space-time seems to warp and twist, hiding secrets within its folds. But we are not deterred. Driven by an insatiable curiosity, we continue to probe the boundaries of knowledge, seeking the answers to the universe's most profound questions. What is the true nature of reality? What are the fundamental building blocks of existence? And what is the code that binds it all together? The search for the universe's hidden patterns is not just a scientific endeavor, it's a deeply personal one. As we delve into the mysteries of the cosmos, we are also exploring the mysteries within ourselves. For the universe is not something separate from us, we are an integral part of it. We are made of the same stardust that forms the stars, and within us lies the same code that governs the cosmos. The patterns we find in nature, the spiral of a seashell, the branching of a tree, the swirl of a galaxy, are reflections of the patterns within us. Our bodies are symphonies of interconnected systems, each following intricate rhythms and cycles. Our minds are vast networks of neurons firing in complex patterns that give rise to our thoughts, emotions, and experiences. The code of existence is not just out there in the universe, it's also within us. It's in our DNA, in the structure of our cells, in the very essence of our being. By understanding the universe's hidden patterns, we come to a deeper understanding of ourselves. We begin to see the interconnectedness of all things and our place within the grand tapestry of existence. Our journey into the heart of the universe's hidden code begins with a leap into a realm stranger than any fiction, the quantum realm. Here, the familiar laws of classical physics, the rules that govern the macroscopic world we perceive with our senses, break down. Intuition falters as we encounter a reality where particles blur into waves, where certainty dissolves into probability, and where the very act of observation shapes the observed. Imagine a world where a single particle can exist in multiple states at once, a world where matter can tunnel through seemingly impenetrable barriers, a world where the future is not predetermined but exists as a hazy cloud of possibilities. This is the perplexing, counterintuitive, and utterly captivating world of quantum mechanics. To understand the universe's code, we must abandon our preconceived notions of reality and embrace the strange, the uncertain, and the downright bizarre. For it is in the heart of this quantum realm that the true nature of existence begins to reveal itself. Perhaps the most famous experiment in quantum mechanics, the double-slit experiment, perfectly encapsulates the paradoxical nature of the quantum world. Imagine shining a beam of light not through one but two closely spaced slits. Classical physics predicts that the light will pass through the slits and create two distinct bands on a screen behind them. However, that's not what happens. Instead, the light behaves like a wave, creating an interference pattern of alternating light and dark bands on the screen. This suggests that the light particles are somehow passing through both slits simultaneously, interfering with themselves like ripples on a pond. But here's where it gets even stranger. If we try to observe which slit each particle goes through, the interference pattern disappears, and we're left with the two distinct bands predicted by classical physics. The act of observation, it seems, collapses the wave function, forcing the particles to choose a single path. This peculiar phenomenon, known as wave-particle duality, lies at the heart of quantum mechanics and challenges our very understanding of the nature of reality. The observer effect, as demonstrated by the double-slit experiment, raises profound questions about the role of consciousness in shaping reality. If the act of observation can alter the behavior of particles, does this imply that consciousness itself has a tangible effect on the physical world? Some physicists believe that consciousness may be the missing piece of the quantum puzzle, suggesting that it is the interaction between the observer and the observed that collapses the wave function and brings reality into focus. Others propose that consciousness may be an emergent property of complex systems, arising from the intricate interplay of quantum processes in the brain. While the debate rages on, one thing is clear: the observer effect highlights the intimate connection between the observer and the observed, suggesting that we are not merely passive witnesses to reality, but active participants in its unfolding. In the quantum realm, certainty gives way to probability. We can no longer predict the exact outcome of an event with absolute certainty, only the likelihood of different outcomes occurring. This inherent uncertainty is not due to a lack of knowledge or limitations in our measuring devices, but a fundamental property of the quantum world. The Heisenberg uncertainty principle, one of the cornerstones of quantum mechanics, states that we can never know both the position and momentum of a particle with perfect accuracy. The more precisely we measure one, the less we know about the other. This inherent uncertainty is not a limitation of our understanding, but a fundamental aspect of reality itself. The quantum world challenges our classical intuition, where we expect objects to have definite properties and events to unfold in a predictable manner. But in the quantum realm, the universe reveals itself to be far more subtle, nuanced, and filled with possibilities than we could have ever imagined. The quantum world is a realm of paradoxes, a place where seemingly contradictory concepts coexist. Particles behave like waves, certainty dissolves into probability, and the act of observation shapes the observed. Rather than shying away from these paradoxes, we must embrace them as gateways to a deeper understanding of reality. Just as the ancient Zen koans challenged students to abandon logic and embrace paradox to attain enlightenment, the paradoxes of quantum mechanics invite us to expand our thinking, to question our assumptions, and to consider new ways of understanding the universe and our place within it. The quantum world reminds us that reality is not always as it seems, that our perception is limited, and that the universe is full of surprises. By embracing the paradoxes, we open ourselves up to a world of wonder, mystery, and infinite possibilities. Quantum mechanics, with all its strangeness and wonder, has revolutionized our understanding of the universe at its most fundamental level. Yet it remains a theory in progress, a work in progress. Physicists are still grappling with its implications, seeking to unify it with Einstein's theory of general relativity, which describes the universe on a cosmic scale. The search for a unified theory, a theory of everything, is one of the greatest challenges facing modern physics. Such a theory would provide a single, elegant framework for understanding the universe, from the smallest subatomic particle to the largest cosmic structure. It would be the ultimate expression of the universe's hidden code, a testament to the elegance and simplicity that lies at the heart of all creation. The journey into the quantum realm is not for the faint of heart. It requires us to abandon our cherished notions of reality, to embrace the unknown, and to question the very nature of existence itself. But the rewards are immeasurable, for in the heart of the quantum world, we catch a glimpse of the universe's hidden code, a code that speaks of unity, interconnectedness, and the boundless potential that lies within us all. Prepare to delve deeper into the quantum realm, where we encounter a phenomenon so bizarre, so counterintuitive that it seems to defy the very fabric of reality itself, to quantum entanglement. Imagine two particles linked in a way that transcends space and time. No matter how far apart they are separated, even if by billions of light years, they remain connected, their fates intertwined. This interconnectedness is not merely a theoretical concept, it's a measurable phenomenon, experimentally verified time and again. When we measure the state of one entangled particle, the state of the other particle instantly collapses into a corresponding state, as if by magic. This spooky action at a distance, as Einstein famously called it, suggests a level of interconnectedness that shatters our classical understanding of the universe. Entanglement implies that the universe is not a collection of isolated objects, but a web of interconnected relationships, a tapestry woven together by invisible threads of quantum correlation. It challenges our very notion of locality, suggesting that particles are bound by the limitations of space and time as we perceive them. Section 2. Bridging the gap from subatomic particles to the cosmos. While entanglement was initially observed in the microscopic world of subatomic particles, its implications reverberate outwards, potentially encompassing the entirety of the cosmos. Could it be that this interconnectedness extends beyond the realm of particles and into the macroscopic world we experience? Some physicists theorize that entanglement could play a role in the formation of galaxies, the behavior of black holes, and even the very structure of space-time itself. The universe, that they suggest, might be a vast network of entangled particles, a cosmic dance of interconnectedness spanning unimaginable distances. This perspective challenges us to consider the possibility that the universe is not a cold, indifferent void, but a living, breathing entity, interconnected at its very core. It suggests that the separation we perceive between ourselves and the cosmos is an illusion, a product of our limited perception. Section 3. Entanglement and the illusion of separation. Entanglement has profound implications for our understanding of ourselves and our place in the universe. If particles can be interconnected across vast distances, could it be that our own minds, our consciousness, are also part of this intricate web of relationships? The idea of interconnected consciousness has been explored by philosophers and mystics for centuries, but entanglement provides a tantalizing scientific framework for understanding this ancient concept. Could it be that our thoughts, emotions, and experiences are not merely our own, but are influenced by and influence the thoughts, emotions, and experiences of others, even across great distances? While the scientific community is still grappling with the implications of entanglement for consciousness, the possibility alone is a potent reminder that we are not isolated beings, but part of something much grander than ourselves. It suggests that the boundaries between self and other, between observer and observed, may be far more fluid and permeable than we perceive. Section 4. The Symphony of Existence, a universe united. Entanglement paints a picture of the universe as a unified whole, a symphony of interconnectedness where every part is inextricably linked to every other part. It suggests that the universe is not a collection of isolated objects, but a dynamic, interconnected web of relationships, a cosmic dance of energy and information. Just as the individual instruments of an orchestra contribute to a harmonious whole, so too do the countless particles, stars, galaxies, and perhaps even consciousnesses contribute to the grand symphony of existence. The universe, from this perspective, is not a cold, indifferent void, but a living, breathing entity, interconnected at its very core. This vision of a unified universe challenges our anthropocentric biases, reminding us that we are not the center of creation, but merely one expression of the universe's infinite creativity. It invites us to embrace a sense of humility, wonder, and interconnectedness with all that is. Section 5. Implications and Possibilities: Unraveling Destiny's Threads. The implications are far-reaching and profound, extending into realms of human experience that we are only beginning to explore. Could entanglement play a role in telepathy, precognition, or other unexplained phenomena between minds and across time? While these questions remain open to scientific inquiry, entanglement provides a tantalizing framework for understanding the interconnectedness of all things. Us to expand our understanding of reality, to embrace the unknown, and to consider the possibility that we are part of something far grander and more mysterious than we ever imagined. As we continue to entanglement, we may discover that the universe is not merely stranger than we imagine, but stranger than we imagine. And in this journey of discovery, we may come to a deeper understanding not only of the universe, but also of ourselves and interconnected tapestry. Section 1. The universe as a hologram, a mind-bending concept. Buckle up, as we're about to venture into a realm where reality itself blurs and our perception of the universe is turned inside out. Imagine, if you will, that everything you see, feel and experience, the vast expanse of space, the intricate dance of galaxies, even the chair you're sitting on, is not solid matter but a projection, a holographic projection emanating from a distant two-dimensional surface. This mind-boggling concept, known as the holographic principle, emerged from the study of black holes, those enigmatic cosmic monsters that devour even light itself. Physicists wrestling with the paradoxes of black holes stumbled upon a startling possibility: that the information about everything that falls into a black hole isn't lost forever but is encoded on its surface, the event horizon. This realization led to the radical idea that perhaps the entire universe, with its three spatial dimensions, could be a holographic projection of information encoded on a distant two-dimensional surface. It's like watching a three-dimensional movie. The illusion of depth and volume is convincing, but the true source of the image lies on a flat screen. Section 2. Information, the building block of reality. To grasp the holographic principle, we need to shift our perspective on the very nature of reality. What if, at its most fundamental level, the universe isn't built from matter and energy, but from information? Think of the pixels on your computer screen. Each pixel carries a specific color value, and together they create the images you see. Similarly, the holographic principle suggests that the universe is woven from a tapestry of information, with each bit contributing to the grand, complex picture of reality. The seeds of the holographic principle were sown in the study of black holes, where gravity is so intense that nothing, not even light, can escape. Black holes presented a profound puzzle for physicists trying to reconcile quantum mechanics with Einstein's theory of general relativity. According to quantum mechanics, information cannot be destroyed, only transformed. However, black holes seem to violate this principle. The breakthrough came when physicists realized that the information about everything that falls into a black hole is actually encoded on its surface, the event horizon. This realization suggested that the entropy of a black hole, a measure of its information content, is proportional to its surface area, not its volume, not its The realization that information could be encoded on a surface rather than within a volume led to the idea that perhaps the entire universe could be a hologram. Just as a hologram projects a three-dimensional image from a two-dimensional surface, perhaps our three-dimensional reality is a projection from a distant two-dimensional boundary. This boundary, often referred to as the holographic screen, would contain all the information needed to describe everything within the universe. It's like a cosmic blueprint, a master code that dictates the unfolding of events within our three-dimensional world. This concept challenges our very notion of reality, suggesting that the universe we perceive as vast and three-dimensional might be an illusion. The holographic principle, if true, has profound implications for our understanding of the universe and our place within it. It suggests that our perception of reality as three-dimensional might be an illusion, a product of the way our brains interpret the information encoded on the holographic screen. This realization challenges us to question the very nature of space and time, suggesting that they, too, might be emergent properties of the underlying information tapestry. The holographic principle is still a theoretical concept, and much research remains to be done to fully understand its implications. However, it offers a tantalizing glimpse into a deeper level of reality, one where information reigns supreme. Our journey into the universe's hidden code takes us deeper into the cosmic abyss, where we encounter a mystery that has baffled astronomers for decades, the enigma of dark matter. When astronomers observed the rotational speeds of galaxies, they stumbled upon a perplexing anomaly that defied the laws of physics as they understood them. Stars on the outskirts of spiral galaxies, like our own Milky Way, were moving far too fast. Based on the visible matter, stars, gas and dust, there wasn't enough gravitational pull to keep these speeding stars from flinging out into space. It was as if an invisible hand was holding these galaxies together, a hidden force accounting for the missing mass. This elusive substance, dubbed dark matter, emits no light, reflects no light, and doesn't interact with ordinary matter in any way we can currently detect. As astronomers delved deeper into the mystery of dark matter, they uncovered a cosmic web of astonishing scale and complexity. It wasn't just scattered randomly throughout the universe, it was intricately structured, forming a vast interconnected network of filaments and halos that spanned billions of light years. Imagine a spider web, its delicate threads tracing out an intricate pattern against the backdrop of the night sky. Now magnify that web to an unimaginable scale, its threads replaced by massive filaments of dark matter, stretching across the cosmos and connecting galaxies like beads on a string. This is the cosmic web, the scaffolding upon which the visible universe is built. Despite its profound influence on the universe, dark matter remains one of the most elusive mysteries in modern astrophysics. Scientists around the world are engaged in a relentless quest to unlock its secrets using a combination of ingenious experiments and sophisticated theoretical models. They're searching for clues in the depths of underground mines, shielded from the interfering noise of cosmic rays, hoping to detect the faintest whispers of dark matter particles interacting with ordinary matter. They are building powerful particle accelerators, smashing atoms together at near-light speeds, seeking to create dark matter particles in the laboratory. Yet despite these efforts, dark matter continues to evade our grasp, its true nature remaining shrouded in mystery. The quest to understand dark matter is more than just a scientific curiosity, it's a journey to understand the fundamental makeup of our universe. If dark matter accounts for roughly 85% of the matter in the universe, as current estimates suggest, then understanding its nature is essential to unlocking the secrets of the cosmos. The search for dark matter is a testament to the human spirit of exploration, our insatiable desire to comprehend the unknown. It's a journey that pushes the boundaries of our knowledge and challenges us to consider possibilities that lie beyond the realm of our current understanding. As we continue to peer into the cosmic abyss, seeking to unravel the enigma of dark matter, we are embarking on a journey of discovery that promises to revolutionize our understanding of the universe. As we journey deeper into the universe's hidden architecture, we begin to discern a language, a subtle yet persistent whisper of order amidst the apparent chaos. This language is not one of spoken words or written symbols, but of patterns, proportions, and mathematical relationships etched into the very fabric of existence. From the smallest atom to the largest galaxy, the universe seems to hum with a symphony of patterns, a testament to an underlying order that transcends our everyday perception. Consider the intricate spiral of a nautilus shell, each chamber perfectly proportioned to the next, following a precise mathematical sequence known as the Fibonacci spiral, or the elegant dance of planets around a star, their orbits governed by the immutable laws of gravity, tracing out elliptical paths with predictable precision. These are not mere coincidences, but reflections of a deeper order, a cosmic code that governs the unfolding of events across the universe. Among the many patterns that permeate the universe, one stands out for its elegance, its ubiquity, and its profound implications. The golden ratio, often represented by the Greek letter phi. This irrational number, approximately 1.618, appears with startling regularity in nature, art, and architecture, suggesting a fundamental principle of aesthetic harmony and structural efficiency. Observe the arrangement of petals in a rose, the branching patterns of a tree, or the spiral arrangement of seeds in a sunflower's head. All exhibit the golden ratio in their proportions. Ancient Greek architects incorporated the golden ratio into their designs, believing it to be aesthetically pleasing and structurally sound. The golden ratio's ubiquity suggests a deep connection between mathematics, aesthetics, and the fundamental structure of the universe. Section 3. Decoding the Matrix, the Promise and Peril of Knowledge. As we delve deeper into the universe's hidden code, we're faced with a profound question. What does it mean to unlock the secrets of existence? Imagine a civilization that discovers the ability to manipulate the very laws of physics, to bend reality to its will. The potential benefits are staggering, eradicating disease, solving energy crises, transcending the limitations of our physical bodies. But with this power comes the potential for unimaginable destruction, the unleashing of forces beyond our control. Section 1. A glimpse beyond the veil. We've journeyed from the subatomic realm, where reality shimmers and bends, to the cosmic web, where galaxies are strung like pearls on threads of dark matter. We've pondered the holographic principle, where our very perception of a three-dimensional universe might be an elaborate projection from a distant, information-rich surface. Through it all, we've begun to glimpse the elegant code beneath, the hidden patterns that whisper of a deeper order. To understand the universe's code is to understand ourselves. The patterns we see in the spiral of a galaxy echo in the curl of a seashell, in the swirl of our fingerprints, in the very structure of our DNA. Section 2. The code within, the code without. The more we learn about the universe's hidden patterns, the more we realize how much we don't know. Dark matter remains elusive, its true nature a tantalizing mystery. The holographic principle, while compelling, is still a theoretical construct, a mind-bending possibility awaiting definitive proof. And the nature of consciousness, its relationship to the quantum realm, remains one of the greatest enigmas of all. Section 3. The journey continues. The search for the universe's hidden code is a journey without end. Each answer we uncover only leads to more questions, each discovery revealing new layers of complexity and wonder. As we stand on the precipice of a new era of scientific discovery, armed with powerful telescopes and sophisticated particle accelerators, we are poised to unlock secrets that previous generations could only dream of. The universe is whispering its secrets, and we are listening.